Awesome. Well, thank you all so much for your time, for joining us on this Tuesday. Especially thank you to the folks who are joining us in off hours. I know some of you are joining from all over the world. This is our Tuesday Live with Astronomer. For those of you who it's your first one, these are shorter, really developer-focused videos that we do to make it so that you learn how to do something very specific with Kent and I here on our bi-weekly Tuesdays. Today's, I'm super excited to talk about the Astro Python SDK and some of the cool things that you can do there. Quick set of notes before we dive in. The video and the accompanying code will be sent over to you an email after, so don't worry about that. And as always, we encourage you to jump in, ask questions in the chat, and we'll get to as many as we can after the content. But with that said, Kent and I will hand it off to you, and let's get started.
Awesome. Sounds good. Thanks, Viraj. So thanks everybody for joining. As Viraj said, we like to keep these Live with Astronomers short and super developer focused. So I'm going to dive into code pretty quickly here. This week, we are continuing to talk about the Astro Python SDK, which had our first 1.0 GA release, probably a month or so ago now. Time really flies. So a couple of weeks ago, we talked about the load file function. Now we're going to talk about a couple of other functions in this SDK. So real quickly, before I dive in and actually show these kind of in action, just to level set in case anybody here is not familiar already, haven't maybe joined our any of the other sessions we've done on the SDK. Just at a high level, it's an open source Python package. It's maintained by Astronomer. It provides tools to improve your DAG authoring experience. So this is going to be really clear as we go through today. But they're going to, reduce the amount of code that you have to write and just make it a lot easier to interact with Airflow, especially for new Airflow users, and to move data around and transform it without a lot of boilerplate code. So that's what functions we're going to talk about today do. With that, I'm going to go ahead and, as promised, just jump right into the code. Just a quick note, and again, don't worry about needing these links or anything, but because we'll send them out afterwards. But to use the SDK, this is the repo. Again, it's fully open source. Anybody can use this. You do need to install it as a Python package in your Airflow environment. So there's instructions for that here. If you're working with like the CLI, you can add this to your requirements text file, or any other way that you install packages into your Airflow environment. Once you have that installed, that's all you really need for prerequisites. And then we can go ahead and jump into using these functions in your DAGs. So the way I'm going to show data frame and transform, I'm actually going to show a before and after example to kind of highlight how they can make this process easier. In general, they are going to be used for kind of ETL or ELT type workflows, maybe like ML ops kind of things. But you have, so these two, transform function is going to be for running SQL transformations, and data frame function is going to be for running Python transformations. So super straightforward. To show this example, I'm going to start with my classic DAG here. So this is going to use non-SDK functions just to kind of level set with what we're trying to do here. So I have a pretty basic flow here. I'm going to load some subscription data, run a couple of extraction and transformation steps on it, and then load it into a final table. So again, pretty classic workflow here. If I look at the code for this, I'm going to focus on these two functions, so the extract and the transform. So what I want to do with my extract, so I've loaded some raw data into, in this case, I'm using Snowflake. And what I want to do is join data from two tables and save it to a data frame that I'm going to process. That's what I want my task to do. This is, again, the classic way. So I'm just using the task decorator. And I can, easily implement this. I'm running this query. So in this case, I'm just unioning these two tables together, but this could be any SQL statement you needed to run. Obviously, to actually run this in Snowflake and save the results to a data frame that I can then use in a downstream task, I have to have a fair amount of boilerplate code. There isn't an operator that's designed to do this within Airflow. So you have like the Snowflake operator, which will run a Snowflake query. So I could run this query, but I wouldn't have access to any of the results afterwards. So in order to do that, I write my own Python function. I use the Snowflake hook to make my connection, run my query, and then I convert all of the results into a data frame using all of this code, and finally return that data frame. And I do that so that in my next task in this transform data, again, I have a Python task decorator here. I'm going to switch to a transformation that's better suited to Python. So in this case, I'm using this melt function, which is kind of like a pivot, sort of an opposite of a pivot, which is sort of notoriously difficult to do in SQL. So I'm doing that, but again, this is the only part that's actually the transformation piece of the code. The rest of this function is just dealing with the data frame from my previous task. So reading it in from XCOM and then saving it back to something that can be reloaded into Snowflake for my final table. So again, just kind of a lot of boilerplate here. I'm using hooks in a function. It's a little bit complex. It's possible, but not super intuitive, especially for newer Airflow users. So let's take a look at what this looks like with the SDK instead. So just to give you a sense, we have the same general flow here. I have 2 load tasks in this one instead of 1 for my 2 files, but otherwise it's the same. I have my extract and my transform, and then I stick it into those results into a table at the end. So now if I look at the code for this DAG, instead, again, we're going to focus on the extract and the transform steps. And you'll notice up at the top here, I am importing a couple of files from the Astro Python SDK. That's from this astro.sql import. I have a whole list here, but the ones we're going to focus on are data frame and transform. So again, transform is going to be used to run SQL query. Data frame is going to be used to run a Python transformation. So to use these functions and their decorators here, so the first one I'm going to do is this transform. All I have to do here is define the SQL query that I want to run. So in my function, I'm going to, again, just provide the SQL where I'm unioning in 2 tables. This function takes 2 tables as inputs. So when I call this function, I'll specify what those are. But transform, all you have to do is provide that SQL statement, and the SDK is going to take care of all of the boilerplate under the hood of pulling that data together and saving the results in an intermediate table that can be used by any downstream task. So no boilerplate required. Similar with story with the data frame function, except for in this case, I can provide it a Python function that I want to run. So again, you'll notice here that I still have this melt function that I'm doing with my data frame, but I don't have to do any of that pulling the value from XCOM, explicitly saving it to a table or to a string that can be reloaded. The SDK takes care of all of that for me under the hood. So I just return the value that I want. To actually run these, I do that down here where I define the task dependencies. So I'm going to call these functions and pass in the data that I want to use. So for this extract data one, remember that's unioning 2 tables together, homes 1 and homes 2. This is Jinja templated, so we can pass these in time. I'm just going to define what those are. And I'm also going to define an output table. So this is the table in my database that's going to store those intermediate results. In this case, I'm passing in the names of other tasks. So those load file tasks that came previously. So again, I don't have to manage that myself. I can say just by passing the task names between each other, similar to how you would do so with the task flow API. The SDK is going to inherit everything it needs, including the database connection, all of that stuff. Then moving on to the transform data task. Again, all I pass in is my data frame. I'm passing in my upstream task, the extracted data. So that's going to say, I want to take the table that this task created and use that as my input data frame. Again, in this particular case for transform, if you want to save the results of your Python transformation from that data frame task back to your database, if you're going to use it downstream, like I am in this case, you just provide this output table parameter. And this is going to save that data frame to a table in your database. If you don't provide this output table, that's totally fine. It will just be saved in whatever you have set up as your XCOM backend. And that's it. So super powerful. Again, we're eliminating a ton of boilerplate code. This makes it really easy to sort of transition between SQL and Python. So you can use whichever one is best for each step in your transformation process without having to worry about doing all of those conversions all the time. And it's really easy to learn. So if you have folks that, are just getting started with Airflow and you're really more comfortable in SQL, then you can just use transform tasks to work that way. If you're more comfortable in Python, you can use data frame tasks or any combination in between. Cool. So I'll pause there. And for those who have joined us live, we're happy to take any questions.
Awesome. Got a couple of questions here, Kenton. One from Nikita, who's asking, how is the data frame itself passed between tasks?
Yeah, great question. So what's going to happen when you use the data frame function is you're returning this as a data frame. And so again, you have an option to specify an output table parameter, in which case that data frame will be saved back to your database and any downstream tasks will read that in. So that's a good option if you have downstream either SQL transforms that you're running, or if you're gonna, use like an append function to put it into a new table. If you don't, if you're moving on to another Python function and you want to keep it sort of locally, quote, you can. The one thing to note there is if you don't have an XCOM backend set up, it will just use normal XCOM, which is your Airflow metadata database. So you want to be really careful with that. If your data is large at all, that can cause some problems. So, and the documentation kind of covers a recommendation on setting up a backend if that's what you're going to do. But that was a really long answer to say that the nitty gritty of how all of that happens is totally taken care of by the SDK for you. So you don't have to worry about, okay, now I want to do some SQL on this data. How do I convert the data frame? All of that. That's all taken care of behind the scenes.
Awesome. And then Kenton, can you just briefly talk about which databases are supported for the SDK right now?
Yes, definitely. So this is, I'm just going to pull up the list. Sorry, I don't butcher it. So these are the current databases, BigQuery, Postgres, Snowflake, or SQLite. We do have Redshift support coming very soon in the next release. So yeah, those are the currently supported ones. If we'll also throw out there that, again, this repo is open source. The link will be included in the follow-up materials. If there's a database you're working with that you really want to see support for, we would love that feedback, and you can definitely submit an issue in this repo.
Awesome. I think that was the last question. Just one more note from us about this is we're really excited about some of the things that we're going to be doing with Astro SDK over the next couple of months, and would love to collaborate more with the community to help implement actual use cases. So if you're interested, if this looks like it'll fit your use case and you're interested in giving it a go, please shoot me an email. I just dropped my email in the chat, and then reach out to me and we can see if we can help you out. But I think as far as this video goes, thank you all so much for joining. This was awesome. Kenton, I love the way you do the before and after on the code. I think it makes it really clear for everyone exactly around how this helps.
Yeah, for sure. Yeah, I'll end just by saying again, we have a whole bunch of additional resources for you to dive in deeper. So you can, yeah, get started with it, and we will be sending this out afterwards, so you can take a look at all of those.
Awesome. All righty. Thanks, everyone. Talk to y'all soon.
Awesome. Bye.